Okay, guys. Good afternoon and happy Sunday. My name is Delzy. I'm from Delzy Tutorials. Okay. Today I'll be taking us on chemistry practicals. The title of the practical is Measurement in Chemistry, Volume Changes Accompanying Mixtures of Liquids. Okay. Now you know that in every practicals there is always an objective. All right. So the objective of this experiment would be to investigate the volume changes upon mixture of liquid. Alright? It's basically to test if there will be a volume conservation or not. Okay? Now, volume conservation basically refers to the expected volume. Would it be the same thing as the actual volume? For instance, if you bring 10 liters of water and of course you mix it with another 10 liters of water, expectedly you should be getting 20 liters of water, right? Yes. And of course, if you carry out the experimental procedure, you bring 10 liters of water, you mix it with another 10 liters of water. In real time, you're still going to get 20 liters of water because the two liquids we are mixing are the same type. Same thing will be applicable if I bring ethanol, 10 liters of ethanol plus another 10 liters of ethanol. But what if I bring different liquids? For instance, I bring ethanol 10 liters and I bring water 10 liters. Now, expectedly, 10 plus 10 is meant to give us 20, right? Fine. But then you realize that when you mix 10 liters of water with 10 liters of ethanol, you're going to get a volume lower than 20. You might get something like 19, you might get 18. So in this case now, our actual volume from calculation is going to give us not 20, it's not going to give us 20, it's going to give us 18 or 19, right? Now, at the end of the day, you're going to compare the actual volume from your calculation with what you expected. Expected volume is the one that you added 10 plus 10 is 20. Now, you realize that by the time you mix 10 liters of water with 10 liters of ethanol, the total volume will not be what you'll be expecting. You'll be expecting 20 because mathematically 10 plus 10 is equals to 20. But in real time, the answer will be less than 20. So in this case now, volume is not conserved because the volume you're going to get from the expected volume, like the expected volume, is not the same thing as the actual volume. Right? Okay? Now, this you always get anytime you're mixing liquids that are not of the same type. Okay? So for this experiment, we have some apparatus we're going to be making use of. This is my glasswares, volumetric flask, precisely 10 ml volumetric flask. Okay, you're going to use this in the lab. You might actually ask you guys to also use 25 ml. Unfortunately, I do not have 25 ml here, but I do have 50 ml just to show us. This is how volumetric flasks look like. If you look at the 50 ml and if you look at the 10 ml, their shape basically is almost the same thing. Okay. Now, you also need a conical flask. Another name for a conical flask, of course, is Erlenmeyer flask. So I have my Erlenmeyer flask here. Basically, we're going to use this in transferring and also measuring of liquids. Now, we have measuring cylinder. Okay, these measuring cylinders, they are all calibrated. So you use this guide to actually measure out a solution and perhaps transfer it to wherever you need. Okay, I have here with me, this is a pipette. Of course, we all know what pipettes are. Pipette is used to transfer liquids. Okay, but if you could recall back then in secondary school, when you were conducting your practicals titration precisely, you realize that most of the times students do suck the pipette with their mouth. Okay, that is actually not the best procedure. What if in the process of trying to suck up the liquid, eventually it passes down your throat? Okay, so you realize that you might be exposed to some certain burns because of the toxicity of the liquid or perhaps the corrosive nature of the liquid. So in order to avoid that, we actually going to be making use of pipette sucker. And this is how pipette sucker looks like. If you actually roll this pulls up. While this guy is pulling up, is dragging up the liquid. If you roll it down, it goes down. How do we make use of it? If you actually look at this, there is an orifice here. There's a hole where you're going to plunge in your pipette. You push it in, and of course you dip it into the solution, and then you drag it up. By so doing, you're taking up the liquids. Okay, so I've actually exposed us to the apparatus, and of course, the last but not the least is weighing balance, which is also known as analytical balance. So we're actually going to use this because most of the time, I don't know if I've explained this before now, but use this to weigh this before and after. Okay. Now, if you look at the board here, I actually drafted out the data table. The data table beside is going to be the table that will be recording our values obtained from the experiment. Subsequently, we're going to use the values here to carry out our calculations. So I'll implore all of us to sit back and, of course, enjoy the practical session. Thank you. Like I said, my name is Delzi from Delzi and White Tutorials.